Good morning to everyone. I'm Dr. Sumi MS. The name of the course is Satellite Communication, and today's lecture topic is Thermal Control and Propulsion from Unit 2 Space Segment. On completion, the students will be able to explain about thermal control, describe the passive techniques for thermal imbalance, as well as understand about propulsion subsystem. Thermal control. It is necessary that the mean spacecraft temperature and the temperature of all the subsystems should be maintained within the limits suitable for satisfactory operation. Moreover, some devices such as valves, thrusters, bearings, and deployment mechanisms may fail to operate completely if the temperature is too high or too low. Sources of radiation. Radiation sources may be from the sun, from the earth, as well as from the earth's albedo, that is, a fraction of radiation falling on earth and getting reflected. Heat generated by the equipments in satellite itself can also be a source of radiation. Passive techniques. Within the spacecraft, thermal balance can be achieved by using simple passive techniques. Some of such techniques are appropriate choices of materials, surface finish, insulation, as well as heat conductors. Optical solar reflectors are used on the north as well as south panels, and antenna is made from graphite epoxy to minimize distortion. Multi-layer insulation is made on rear side of antenna reflector and tower to minimize thermal gradients, as well as rear surface of solar panels is painted black for high emittance, and east and west panels of satellite of the spacecraft are covered with multi-layer insulation. These are some of the passive techniques. Active methods. Thermal blankets and shields are used to provide insulation. Radiation mirrors are used to remove heat from the communication payload. In Huck's HS 376 satellite, a mirrored thermal radiator is being used. This radiator provides path for the generated heat to escape into the surrounding space. When the transponders are switched off, there will be heat reduction in the satellites. And to compensate heat, heaters may be switched on at that times by giving command from the ground. Propulsion. A propulsion subsystem is required for a communication satellite to maintain a proper orientation and spin rate in transfer orbit, to inject the satellite into geostationary orbit, to maintain the satellite at the correct longitude in the equatorial plane by station keeping, and also to help in attitude control. The propellant used for propulsion can be liquid or gas. Specific impulse. This is the characteristic that is used to describe the propellant performance, and it is defined as the ratio between the thrust in terms of units of force to the rate of propellant flow in terms of units of weight per time. Reaction control subsystem. A liquid propellant is used for transfer and drift orbit maneuvers, station keeping, as well as attitude control. The liquid propellant subsystem is known as the reaction control subsystem, and the propellant employed is hydrogen. Early propulsion systems. Early propulsion systems used cold gases as propellants, and some examples are nitrogen as well as hydrogen peroxide. These systems had very low specific impulses when compared with liquid propellant systems. And the two common types of propulsion systems are monopropellant system as well as bipropellant systems. Monopropellant system. These are liquid propulsion systems that use hydrazine as the propellant, and due to the hydrazine, the liquid with a boiling point of 114 degrees Celsius and freezing point of 2 degrees Celsius, and a specific impulse of such systems is 220 seconds. Bipropellant systems. These are also liquid propulsion systems, but their performance is higher compared to the monopropellant systems. Such systems are especially used for large spacecraft, and the fuel employed is monomethyl hydrazine. They have high specific impulse in the range of 290 seconds to 310 seconds. Also, they have restart capability, and the errors are corrected with less expense of fuel. quiz questions on thermal control and propulsion. What are the passive techniques involved in thermal balance? Give a note on propulsion subsystem. What do you mean by bipropellant system? Thank you.